for part B is pretty straightforward. The only thing you have to keep in mind for part B is that your shear stresses are going to be you're going to superimpose them. So torsional stress acts radially. I feel like I'm not using that word correctly, but I hope you get my drift. It's going to act like this. You have the most torsional stress furthest from the center. At the center, you have zero torsional stress, and I believe that is reflected in your equation sheet. Yes, it is reflected here. When R is equal to 0, you have your minimum, you have no torsional stress. That's basically saying if you're at the center point, you have no torsion stress. If you're all the way at the far end of the circle, then you have your maximum torsion stress. The reason why this is important is because in part B, you're interested in finding the maximum P that you're allowed to exert. But you need to use this shear stress, this maximum tau. In order to do that, you cannot compare these two things individually. You have to sum them up. But you can't just add them per se. Notice how this one, the top one is acting this way. The shear stress is acting this way. And this one, the bottom shear stress is acting this way. The shear stress due to actual shear, V, is going this way. You need to use the point where the shear stresses are acting in the same direction. And I hope this should be clear when I draw it this way. Like if you have shear stress going this way and you have shear stress going this way, well, clearly some of them are going to cancel each other out. Yes. So you need to use this. And you might be asking, well, how do I know which direction the shear is acting in? I realized that this is, I don't know how many of you thought of this. It didn't occur to me until after office hours, so I hope I didn't confuse anyone. But you're basing the direction of the shear on, and I hope this is correct, on the direction of the distortion. So because my cylinder is deflecting this way, I'm saying that shear is acting this way. Likewise, because my circle, let's draw this as a square just so this will become more obvious. I'm twisting in this, right? So it becomes like this. The shear stress is acting this way. It's causing rotation this way. Therefore, the shear stress must be this way. And what that tells you is that the maximum shear stress should be at the bottom. You need to add the shear stress due to torsion plus the shear stress due to shear. And that will give you the tau that you saw for this equation. You're going to be able to express these terms. You're going to be able to express tau in terms of P. You're going to be able to express sigma in terms of P, and then you're going to plug in all the values you have here. You're given all this information. You're going to plug all of this information into here and solve for P. You're going to get a P due to tau, a P max, and a P max from sigma, and you want to use the smallest. Okay, I believe that is everything you need to solve the problem. This video is a little bit long, but a lot of people had questions on this in office hours, so I want to make sure that everything here was clear. And you use a lot of this stuff in problem 3, so it will be for good use. But yeah, let us know if you have any questions. I will try to be in the office after Friday, or on Friday, before this is due. So if you have any last minute questions, I will be there. I don't think I'll be available on Thursday, and this probably won't reach you before Wednesday. So yeah, but I'll try to be in the office on Friday. Let us know if you have any other questions.